These are our notes on area of a trapezoid and also cutting up figures into different pieces to find the area. The area of a trapezoid is capital A equals 1/2. H stands for the height of the trapezoid. Then notice in parentheses is B1 and B2. These B's are the bases of the trapezoid. The same thing in triangles and rhombuses. If you remember, you can say multiply by 1/2 or divide by 2. So this is what it looks like if you're dividing by 2. Make sure you write these formulas on your formula sheet for easy reference in the future. So here we have a trapezoid. Remember what I said, the height is perpendicular to the base. And remember, trapezoids have 2 bases. So the formula for the trapezoid again is area equals 1/2 times the height and base 1 plus base 2. Okay, so we can see here that the height for this trapezoid is 4. So if we set that up into our equation, into our formula, we'd have area equals 1/2. Our height, like we said, is 4. And then our bases are the parallel sides here. So we have 12 and 18. So we put 12 plus 18. And 4 divided by 2 would be 2 times 12 plus 18 is 30. So when we solve for that, we'd get 60 units squared equals our area for this trapezoid. Here's another example of a trapezoid. Here's our 90-degree angle here, which means this is our height. We don't know the length of it, so we're just going to call that x for now. The things that are parallel here, those are my bases. So one base is 25 centimeters and one is 40 centimeters. One thing we want to look at so far, our bases, if we have from here to here is 25, then we know that from here to here is also 25. And if the whole thing is 40, I can take 40 minus 25, and that will leave me with a length of 15 for this segment. So if I use 15, the x, and the 25, I can set up the Pythagorean theorem. So if you set up the Pythagorean theorem, you're going to get 15 squared plus x squared equals 25 squared. So when we solve for that, we're trying to find our x, and we would get x equals 20. So now I know that my height right here is 20. So when I set up my formula, I'm going to set it up over here. I can say area equals 1/2 times 20, and then I've got to put in my bases, which were 25 plus 40. And remember, the full length was 40. Don't forget that of your base. So that's how we get the 25 plus 40. So when we solve for this, we can figure out that 20 divided by 2 is 10, and then 40 plus 25 would be 65. So we would find that our area would be equal to 650, and we were working with centimeters, so that would be centimeters squared. Make sure you're careful to keep your measurements in line when you're using the formula for area of a trapezoid, so that your base 1 and base 2 have to be the full length of your bases. Don't forget that, because sometimes that can get confusing. So this is what we should have calculated as our area. Another trapezoid example. It has one set of parallel sides, and the thing you'll notice within any shape is sometimes the height isn't even drawn in for you. So you're allowed to draw in your own height. So I'm going to draw in my dotted line and make the 90 degrees. So I'm going to draw it right here and make my 90 degrees here to show that this is my height. So you'll need to interpret this one a little. So if from here to here is 8, then from here to here would also be 8. Then if you'll notice here, we still don't know the length of this whole bottom base of the whole thing. And we don't know the height, but what we do know is that this angle is 60 degrees. So if you go back to geometry A, if we have one angle is 60 degrees and this is 90 degrees, then this other angle up here has to be 30 degrees for this triangle to equal 180. So you can do a couple of things. I can call this length X, and I can call this length Y. You can use trig to solve for these two sides, or you can use the rules of the 30, 60, 90 triangle. So if you remember, for the 30, 60, 90, we would have 30 would be your x, and then x square root of 3, and then 2x. So in this case, we know our hypotenuse right here is 4, which is across from the 90. So we could label this one as 4. So if we solve for this, we know 2x equals 4, so x equals 2. So if I go back up here, I know that across from my 30 is 2, and across from my 60 would be 2 square roots of 3. So this one would be 2, this would be 2 square roots of 3. And then we already knew that this was 4. So if I go back to my formula, area equals 1/2 height, which is 2/3. Okay, and that can be converted to a decimal. If you wanted to, you can convert that to a decimal. So I'm just going to write this in here, 1/2 times 2 square roots of 3. And then in my parentheses are my two bases, which I know I have 8 plus, this one is 8, but we have to add on that additional 2, so it would actually be 8 plus 10. And if I take 1/2 times 2 square roots of 3, I know that, if I write it out, I know that my 2's cancel out. Sorry, I wrote that wrong. 2's cancel out. So you'd have square root of 3 times 8 plus 10 would be 18. And that would equal 31.2 units squared would be your area for that. And that's what we would give our answer as. So in this last example we're going to do together, I'm going to look at splitting this figure up into more than one shape. It's similar to finding the area of a shaded region. If you look at this figure, we can see that it has 4 sides. It's a quadrilateral, but what can happen is I can piece this picture out, and I can use this triangle, if I just draw this dotted line, and I can use this triangle and then this trapezoid. So if the triangle is 1/2 the base of this triangle times the height, so if we take that, we can say 1/2 times, you can see here, times our height, or times our base, times our height. So if we have 1/2 of 14 is 7 times 5, then our area here is going to be 35 units squared, and I can put that right in here. That's the area of our triangle is 35. Then if you notice the second part, this is a trapezoid. This is parallel to this. So for the area is 1/2. So we can write down here 1/2 the height, and the height is perpendicular to the base. So in this case, since we know our bases are here, this has to be our height. Here's our right angle, and here's our 90. So here's our height. Sometimes the height of a trapezoid is on the inside, and sometimes it's actually on the trapezoid. So our height for this one is 8. So we're going to say times 8. And then we have to add together our two bases. This was the height of our triangle, but it's also one of our bases in the trapezoid. So we can say here 14 plus, we need our other base, which is 14 plus 4, so that gives us 18. So 1/2 of 8 would be 4 times 14 plus 18 is 32. So that equals 128. So if you add up our two areas, we have 35 for the triangle plus the trapezoid was 128, and that equals 163 units squared is our area for the entire figure. Okay, so that's what we'd end up with for our answer for the whole thing. On this last one, these last ones are cutting up figures to find the area. These are going to be your two homework problems for you to work out on your own and see how you do. Good luck.